This guide section covers the Houdini USD workflow in Prism. The introduction guide provides an overview of Prism's capabilities and presets within Houdini Solaris. Additionally, it shows how to properly set up USD assets and shots. The subsequent guides go through the entire pipeline, from asset creation to shot completion. They cover modeling, surfacing, rigging, layout, animation, character effects, and lighting. The following introduces Prism's HDAs and presets. As shown in the Houdini basic guides, a Prism file cache HDA can be used in Houdini's geometry context called SOPs to export to different file formats. Similarly, the Prism import file HDA can be used to import various file formats. With the Prism USD plugin enabled and by switching to the Houdini Solaris workspace, which is built around Houdini's lighting and look development context called LOPS, to manage USD scenes, additional HDAs and presets are available. In Solaris, the Prism file cache HDA can be used to export a USD container, a USD layer, or a USD sublayer. In the advanced settings, additional USD-related options are available. The Prism Import HDA can be used to import USD files from the Prism project into Solaris. These can be imported as layer, as payload, or as reference. In the advanced settings, additional USD-related options are available. The Prism Mute Departments HDA provides options to mute specific department layers or sublayers of a USD stage. The Prism Render HDA can be used to render the input USD stage and save the output images in the Prism project. Additionally, render jobs can be submitted to Deadline. The Prism Sequencer HDA can be used to play back all input USD stages in sequence. It detects the frame range for each input and sets the correct start frame offset. To automate the USD workflow further, the Prism presets are available. They already include the HDAs shown earlier and provide a default structure to work with. The HDAs are intended for use if additional functionality is required within the presets or when presets are created from scratch. The Import Assets preset opens the library window to import assets into the shot node graph. The Setup Current Department preset will set up the department according to the department from which the scene file originates. This preset can be used if the overall workflow is department-based. The Setup Departments preset will set up multiple selectable departments for an asset or shot, depending on the entity of the scene file. This preset is useful when multiple departments are working in a single scene file. The Setup Assets preset allows one or more assets to be selected from the current project, along with the relevant departments, which are then set up all together. This preset is useful when artists are working on multiple assets in a single scene file. The Setup Shots preset allows one or more shots to be selected from the current project at once, along with the relevant departments, which are then set up all together. Note that this preset should only be used within sequence scene files, as shot switch nodes are only created there, which are necessary for the multi-shot workflow. And the new preset can be used to create custom presets from the current stage. To ensure that Prism has the correct context, a new asset and a new shot are now being created. First, a robot asset will be created with the character preset enabled, and Prism creates all predefined departments, tasks, and default scene files in the background. Additionally, For each created asset, Prism automatically defines an asset USD container, including all USD department layers, which are visible in the Products tab. For a better overview, the Prism USD editor can be opened. On the left side, the USD layer hierarchy shows the asset department layers. In the center, the USD scene graph shows the primitives of the asset USD container. And on the right side, the USD viewer gives a preview of the content. Shots can be created in the same way as assets. With the default preset enabled, Prism creates all predefined departments, tasks, and default scene files in the background. Additionally, for each created shot, Prism automatically defines a shot USD container, including all USD department layers, which are visible in the Products tab. As an example, the character effects and effects layers are missing. Therefore, the missing departments can be added at any time. Note that for each department that is created, Prism defines a USD department layer in the background and integrates it into the existing USD container. For a better overview, the Prism USD editor can be opened. This time, the USD layer hierarchy shows all the shot department layers, and the USD scene graph shows the corresponding primitives. The robot asset, including the departments, has already been set up as part of the introduction, and the asset USD container was defined by Prism in the background. To get started with modeling, open the empty scene file. And since the modeling scene is loaded, the Setup Current Department preset will apply the modeling template and load in the corresponding asset USD container. By default, Prism creates a cube inside the SopCreate node. From here, the modeling process can be started. Once the modeling of the character is complete, the geometry can be published to the USD modeling layer. By default, the import path prefix of the SopCreate node is set to the correct geoprimitive to maintain a clean hierarchy. To publish the modeling, select the Department File Cache node in the Export section, add a comment, and click Execute. While the export can be viewed in the Houdini project browser, it is recommended to use the standalone project browser. Open the USD editor and the finished character model can be previewed inside the USD viewer. In addition, the object hierarchy can be viewed, which matches the hierarchy in the Houdini scene graph. Note that all data created in the modeling department is now saved onto the USD modeling department layer and can be muted by toggling the checkbox. If a layer is muted, the corresponding objects are invisible in the USD viewer as well as in the USD scene graph. To begin with surfacing, open the empty scene file. The Setup Current Department preset will apply the surfacing template and load in the asset USD container, including the modeling publish. By default, Prism creates a material library node with a green material X material and assigns it to all incoming geometry. From here, the surfacing process can be started. Once the surfacing of the character is complete, the materials and the material bindings can be published to the USD surfacing layer. By default, the import path prefix of the material library node is set to the correct MTL primitive to maintain a clean hierarchy. To publish the surfacing, select the Department File Cache node in the Export section, add a comment, and click Execute. In the standalone project browser, open the USD editor and the finished surfacing can be previewed inside the USD viewer. In addition, all materials can be seen in the object hierarchy. Note that all data created in the surfacing department is now saved onto the USD surfacing department layer and can be muted by toggling the checkbox. To get started with rigging, open the empty scene file. The Setup Current Department preset will apply the rigging template and load in the asset USD container. By default, Prism creates a rig setup node with a basic Apex rig inside and assigns it to all incoming geometry. From here, the rigging process can be started. Once the rigging of the character is complete, the rig can be published to the USD rigging layer. First, however, the rig needs to be saved as a separate product in the BGO file format. Click Save to Disk to export the product. To publish the rigging, select the Department File Cache node in the Export section, add a comment and click Execute. In the standalone project browser, open the USD editor and no changes are visible. However, all data created in the rigging department is now saved onto the USD rigging department layer. Looking at the rigging layer in plain text shows that a reference has been set to the Houdini rig, which was published as a separate product and is located next to the Asset USD container. Note that this workflow is designed to access the rig inside the animation department. The exact steps will be covered in the Houdini USD guide for animation. A shot including the departments has already been created as part of the introduction, and the shot USD container was defined by Prism in the background. Since many elements come together in the layout department, assets can be connected to a shot. This is beneficial as the assets are automatically imported within the department preset. Right-click on the shot and select Connect Assets. Select the desired assets and click Apply. A confirmation message shows the connected assets. To begin with layout, open the empty scene file, and since the layout scene is loaded, the Setup Current Department preset will apply the layout template and load in the corresponding shot USD container. By default, Prism creates a camera. In addition, all connected assets are imported within a subnet node. In case the Connect Assets feature is not in use, assets can be imported directly via the Import Assets preset. From here, the scene assembly process can be started. Once the scene assembling has been completed, the layout can be published to the USD layout layer. Usually the department file cache node can be used to publish the layout to the department layer. However, to maintain a clean structure, the camera animation will be saved to a camera's sublayer, while all assets will be saved to a second sublayer called assembly. Sublayers can be created using the Prism actions. Right-click on the last node that should remain part of the camera's sublayer. Click on Prism Actions, select Setup Sublayer, and choose the camera's sublayer. Confirm with Setup, and Prism will set up a layer break node along with a sublayer file cache node. Repeat these steps for the assembly sublayer. Once everything has been set up, both sublayers can be executed. Note that if sublayers are in use, do not use the department file cache node. Otherwise, it will overwrite the sublayer hierarchy. In the standalone project browser, open the USD editor and the finished layout scene can be previewed inside the USD viewer. In addition, the camera as well as the assets can be seen in the object hierarchy. Note that the camera data is now saved onto the camera's sublayer, and all assets are saved onto the assembly sublayer. To get started with animation, open the empty scene file. The Setup Current Department preset will apply the animation template and load in the shot USD container. In the rigging guide, the character rig was saved as a separate product, which can now be loaded using the Prism actions. Right-click the In Animation node, click on Prism Actions and select Load Rigs. Choose the operator rig and confirm with load. Inside the SOP context, the animation process can be started using the Scene Animate node. Once the operator animation is completed, as well as the animation of the assistant and commander character, the animation data can be published to the USD animation layer. Like in the layout department, each character animation will now be published to a separate sublayer. The setup sublayer action will be used to set up each sublayer. Change the sublayer name to the relevant character, enter a comment, and publish the sublayer. Repeat the steps for the remaining two characters. In the standalone project browser, open the USD editor and the animated scene can be previewed inside the USD viewer. Note that each character animation is now saved as a sublayer of the animation layer and can be muted by toggling the corresponding checkbox. For a second iteration of the character animations, the export process can be accelerated by selecting all sublayer file cache nodes at once. Add a comment and click Execute. All sublayers will now be published one after the other. The USD viewer now shows the updated animations, where this time the robot turns in the other direction. Furthermore, all sublayers are now on version 2. To begin with character effects, open the empty scene file. The Setup Current Department preset will apply the character effects template and load in the shot USD container. Effects can now be created in the work area. For all robot characters, the eye tentacles will be simulated. To manipulate the geometry of the eyes, a SOP Modify node will be created. From here, the simulation can be set up. Once the simulation is completed, the changes can be published to the USD character effects layer. Since the setup is lightweight, all character simulations will be saved to the department layer. Select the department file cache node in the export section, add a comment, and click Execute. In the standalone project browser, open the USD editor, and the character effects can be previewed inside the USD viewer. Note that the simulation data is now saved onto the USD character effects department layer and can be muted by toggling the checkbox. To get started with effects, open the empty scene file. The Setup Current Department preset will apply the effects template and load in the shot USD container. Effects can now be created in the work area. Smoke will appear in the shot when the robot operator drills through the construction panel. Therefore, add a SOP Create node and name it accordingly. From here, the smoke simulation can be set up. Once the simulation is completed, the changes can be published to the USD effects layer. Since the smoke simulation is heavier compared to the previous simulation created in the character effects guide, the smoke will be exported as a separate product as a VDB cache. Create a Prism file cache node inside the SOP context at the end of the simulation tree. Add a product name and change the format to VDB. Although the VDB cache has been chosen in this case, file sequences of any other format, such as BGO or USDC, can be used as well. In the advanced settings, the Set USD Sample Frame checkbox needs to be enabled. With that, metadata will be added to the cache. This is important in order to reference the cache into the USD layer. Add a comment and click Save to Disk to export the smoke cache. In order to reference the VDB cache into the USD effects layer, the Prism actions will be used. Right-click the In-Work node. Click on Prism Actions and select Load Product Sequence. Select the FX Smoke product below the shot USD container and choose the master version. This will bring in a geometry clip sequence node that references the cache for each frame. By default, the simulation will be loaded under caches. However, to keep a clean hierarchy, the primitive path will be changed. A material for the smoke has already been created and a copy can be added to the main branch. Since further effects may be added to the shot in the future, the smoke simulation will be added to a sublayer to keep things tidy. Right-click on the last node that should remain part of the smoke sublayer. Click on Prism Actions, select Setup Sublayer, name the sublayer and confirm with Setup. The same steps can be followed to create additional sublayers within the effects department. Once everything has been set up, the smoke sublayer can be executed. Note that if sublayers are in use, do not use the department file cache node, otherwise it will overwrite the sublayer hierarchy. In the standalone project browser, open the USD editor, and no changes are visible. However, all data created for the smoke simulation is now saved onto the smoke sublayer. Looking at the smoke sublayer in plain text shows that a reference has been set for each frame to the VDB cache. Although the smoke simulation is not visible in the USD viewer, it can be viewed and rendered in Houdini when loading the shot USD container. Note that this setup comes with the advantage that once everything has been set up, the effects artist can continue to iterate within the SOP context, and only needs to version up the VDB cache. Since the smoke sublayer references the master version of the VDB cache, there is no need to republish the smoke sublayer. In addition, this improves the performance of heavy caches, which can be saved as a file for each frame while keeping the USD sublayer file lightweight. To begin with lighting, open the empty scene file. The Setup Current Department preset will apply the lighting template and load in the shot USD container. Lights can now be created in the work area. From here, the lighting process can be started. Once the lighting is completed, the shot can be rendered and saved to disk. As shown in the layout guide, Prism creates a camera node and a render settings node by default. To adjust the settings for the rendering process, a camera edit node and a render settings edit node can be created. As an example, the depth of field can be adjusted for the camera or the render samples can be increased. Alternatively, the Karma Render Settings node or the Arnold Render Settings node can be used as well. Once everything is set, the rendering process can be executed with the Prism Render node in the Export section. Add a comment, check Submit Job, and click Execute to submit the render job to deadline. For local rendering, uncheck the Submit Job and publish the render. After the rendering has been completed, open the media browser to playback and review the lighting shot. Double-click the media preview to review the shot in OpenRV. To make the lights available in Unreal Engine or other DCCs, the lights can be published to the USD lighting layer. Select the Prism Render node, click Setup File Cache, add a comment and click Execute. In the standalone project browser, open the USD editor and the lighting can be previewed inside the USD viewer. Note that all lights are now saved onto the USD lighting department layer and can be muted by toggling the checkbox.